coin change. You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each coin. So let's state these. These are the key things that we have to pay attention to, and also this. So, for example, one, these are our coins, an infinite number of each coin, and our amount is 11. We have 3 because we can use 2 5s from these coins. We still have an infinite value, of each coins, plus 1, and we get 11. And then in this example, we have a -1 output because we have only 2 values, coins, coins with only 2, since this is an infinite value, but our amount is 3. So since we can use any amount of 2 to add up to 3, we have an infinite 1. And in this example, our coin, we only have ones, and our amount is 0 since we don't need anything to add up to 0. Our output is 0. So this is a dynamic programming problem. Dynamic programming problem. Let's initialize. So we will use a table, initialize a table, a DP table, no list, to store our values. This will be updated. These values will be updated to the minimum values that we come up with. Let's call our list DP, and then make a float, and then a float, and then give it the highest possible value. Use that will be infinite times the amount that we have plus 1. Let's make them inside parentheses. Oops, they should go outside of this. Plus amount parentheses amount plus 1. So in this case, this will be a 12 because we're going to start from an index of 0 up to that amount, which will be 11. For example, amount plus 1 is to account for every index leading up to our amount plus our amount value. And then we'll use dp float, float infinite value is to give our values in each index the highest possible infinity number to compare it later to possible to a minimum value. DP one value will be 0. Index of 0 will be 0. So for example here, amount 0 will be 0. Give index 0. 0 value. Since amount 0 doesn't need any coins to add up to it. So now let's loop through every coin. So let's loop through the amounts in our list. So for I, starting from index 1. For I in the range of 1 to amount plus 1, or we can just put len of amount, which is much more simpler to understand. For every amount, let's check all the appropriate coins. For many months. So these appropriate coins will be explained later on. So for coin in coins, before moving to the next amount in the array, so for coin in coins, if the coin is coin has to be less than or equals to our amount to use it. So if coin is equals to less than or equals to I index, which is our amount, let's make DPI I value of an index to be equals to the minimum, the lowest DI, or DI minus the value I minus the coin, the index value of I minus the coin, plus 1. So we add one more coin to it. And then and that's basically it. So for example here, we will since so we since it's at infinity right now, wait, hold on, wait, no, so this is so our dp is here and our amounts, so we'll check, we'll go to our amount starting from the index of 0, which is a 0, and then 1, which will be amount 1. So we go to the coins, for coin in coins. So we go to 1, we have 1 is 1 less than or equals to I at index 1. I, yes, it's equals to I. So that's the only one that's the only coin that can be used for that index. And so we use the minimum. This one right now, it's at infinity value that we gave it here. So since it will always be less than whatever value that we have here will be less the minimum value. So I 1 minus 1, 1 here plus 1, 1 minus 1 is 0, plus 1 is 1, so that's 1. So we need only one coin to get to index to get the value of the amount 1. That's the lowest minimum possible value for 1. Minimum here and that will take place of infinity from index 1. And then we move on to the next one, index 2. So we can also use index 1 for that, and then coin 1 for that, and then we use it's still at infinity, that one is still at infinity, and then we use 1 minus coin is 1. It's 1 minus 2 will be 1 plus 1 will be 2. So we need 2 coins, but we can have a lower value than that. So that will be here next to so move on to that to 2, and then we go on down and down. Since 2 also meets this condition, we can use coin 2. It's equals to I, so that will be 2 minus 2, that will be 0 plus 1. Since that's the lowest against the 2 here, that will be the minimum so far. Since this one doesn't meet this condition, 5 doesn't meet this, we have to move on to the next I coin, the next amount inside our list. So now replace di with the lowest possible lowest minimum coins needed for the combination to occur, to happen. Used the combination. And that's basically it. So let's move on to check to get our outputs. So let's account for this negative one. So that will be, let's move out of this loop, align to this. So for d amount, dp amount, dp amount equals to, compare it to float. If this hasn't changed in the float. That means we don't have a possible lowest value. So infinite infinite return. Oops, this should be if return -1, else return dp amount. Wait, what is this account? Should be amount. If we don't have a coin combination that adds up to our amount. So let's check for any syntax errors. Let's see if it works. For I in the range of, oops, it should be dp. So the length of dp of the list that we have here. Index for dp. Oh, this should be dp. What's this di? And it's been accepted, and this can be quite lengthy to test. That's why I haven't been able to use all numbers. The time and space complexity, time complexity is quite, it's time complexity is let's call it let's call it t plus e coins plus times or m plus n. M plus n doesn't matter. M plus c or whatever it is that you want to do. So it's basically being times multiplied. Space complexity is of amount, because our amount, our list will increase based on our length of our list, based on the length of our list. And that's basically it for this problem. Let's submit it to see how it goes. And it's been able to pass all cases. So this problem can be takes quite a long time to be able to test every single number that adds up to this. So basically, once we get to 2, and then since we need, so and for in order to test 5, to put 5 inside, use 5, our coin has to be, our I value has to be 5 or more in order to use the 5 coin. And that's basically it for this problem.